Hello, welcome back to my channel. Today I'll be going over mole conversions. So with mole conversions, it's when you convert from one unit to another, and I have already written down the ratios that we'll be using. So with 1 mole, it equals the molar mass of whatever element or whatever compound that you're working with. So whenever you're calculating the molar mass of, let's say, H2O, so like the molar mass of H2O is 18.015 grams, so 18.015 grams of H2O is 1 mole of H2O, of water. And then also with particles, we use the Avogadro number, 6.02 times 10 to the power 23. So this is basically the standard number for particles, or atoms, or molecules. I've written all these down, so whenever you see any of these three, they're the same thing. So these three units are associated with 6.02 times 10 to the power 23. All right, so I'm going to start off with an example of how to convert. So for example, let's say first we're going to do a one-step conversion, like 2 times, and then a 2-step conversion. So we're going to do a mole to mass conversion, and I should probably use a different pen for this. That's better. So let's say I ask how many grams are in 0.67 mole of NaCl. Okay, so my trick is, or my advice to you is that whenever you see grams of anything, I would go ahead and already find the molar mass of NaCl, and I have another video on that, on how to calculate molar mass. So I would do that to the side, so that way when you do the conversion, you already have that ready, because any grams in the question, you're going to be expected to include the molar mass of the compound anyway. So molar mass of NaCl, let me put that to the side. We have Na, which is 22.990, and we have Cl, which is 35.453. And as a reminder, how I got these numbers, I get them from the periodic table. So 22.99 for Na and 35.453 for Cl. And I'm just going to add these together. You should get 58.443, and we're going to eventually use that in our conversion. So back to the question. How many grams are in 0.67 moles of NaCl? We always start with what we're given. And I like to call this train tracks. It's basically, we're building ratios, so that way when we calculate, we know what to multiply, what we divide. And always include units when it comes to doing your conversion, because if you just put 0.67, you don't know what happens next. Like 0.67 of what? Like, is it grams? Is it moles? Is it particles? We don't know. So write down the unit, so that way we know, okay, I know what to put up here and in the bottom. So since we want grams, we want to cancel out the moles, so that way we get to do grams. All right. So since we have mole of NaCl, and you'll see why we include units. Since we want to cancel out the moles, we need to put that in the opposite side, so that way we can cancel that out. Mole NaCl. Don't carry the number down. We have to cancel out the unit, not the number. All right, because we are calculating the number. Okay, so we have mole of NaCl, and according to the ratios that we have up here, 1 mole equals the molar mass. So 1 mole equals the molar mass of NaCl, which we found up here, or right here. So 58.443. Okay, so now that we have gotten rid of these units and we have our grams up here, which is exactly what we want, now we calculate. Alright, so what do we do up here? Do not add. It's very tempting to do that. We have to multiply. So it'll be 0.67 times, written that wrong, times 58.443, and then we divide by the bottom. And in this case, it's just divided by 1, so it doesn't really matter. You're just going to multiply 0.67 times 443. I'm going to go ahead and figure that out. And I'm going to round to 3 decimal places, so I got 39.157 grams of NaCl. So this is my one-step conversion from mole to mass. Alright, so I'm going to give you one example, and you're going to try this by yourself. I would do the same steps that I did. Find the molar mass of whatever compound that I give you, and then you try to do your train tracks. So, how many grams are in 1.25 mole of H2O? So go ahead and figure that out. Pause the video, and then when you're done, unpause and check your work. Alright, so this is what you should get as your final answer, 22.519 grams of H2O. So my molar mass of water, I did that first. I got 18.015, and then I plugged it in. So I start with what I'm given, the 1.25 mole of H2O. I hope you add in units, because that tells you that I need to put 1 mole of H2O, and then I put the grams of H2O up here because that is exactly what we want. That's what it's asking. And then when I plug it in, it's just 1.25 times 18.015, and then divided by 1, which again doesn't matter, 22.519. Alright, so this is an example of the one step. And I'm going to do one more of the using the Avogadro number. So I'm going to do mole to particle. Particles are in 1.56 moles of H2O. Alright, so also another thing that you can do just to make things a little easier, I would kind of just highlight or underline what you're given here, and then you figure out, okay, which of these two ratios do I use? So when you look at the question, like, okay, I have particles, which is what I want, and I have moles, which is what I have. Mole, particles, which one has these two? This is the ratio that I need to use, so I know that I have to use this number. I don't use the molar mass, okay? Because a common mistake is that once you do a lot of this, it's common mistake to just calculate molar mass over and over again, and then it's not what it's asking here. So I would look at, okay, I don't need to do molar mass here, I have to use this number. Alright, so, but the steps with the train tracks, it is the same. Alright, so if I start with 1.56 mole of H2O, again, don't forget your units. So I have mole of H2O, bring it down here, and according to the ratio, according to the ratio, it is 1 mole. And then on top, we put the Avogadro number. And then we solve. So we cancel out the mole, and we just multiply. 1.56 times 6.02 times 10 to the power 23. We should be able to get 9.39 times 10 to the power 23 atoms. Or not atoms. I mean, atoms is the same, but it is asking for particles, H2O. Alright, so I'll give you one other example. But I'm going to switch it up a little bit. How many moles are in 3.35 times 10 to the power 24 particles of CO2? Alright, notice I kind of switched them up a bit, so it's important to know where you place the numbers. So I'm going to have you try this by yourself, and again, you're going to use the same ratio, and try it. Pause the video and then unpause once you are done to check your work. Alright, so this should be your final answer. Notice how I divided this time instead of multiplying, because I start with particles, and particles of CO2, I need to bring that down here to cancel that out, and then I put 1 mole on top. So since we like multiply and then divide, so 3.35 to the power 24 times 1 and times 1 doesn't change anything, and then I divide by the bottom. So I divided these two and I got 5.565 moles of CO2. Alright, so this is pretty much it for the one-step conversions. I'll make a part 2 on two-step conversions, so I hope this helps. So stay tuned for part 2, and thanks for watching.